Hi there, and welcome to the next video, which deals with equations which have brackets in them. Hopefully by the end of this video you'll have some ideas as to what to do with the brackets and how best to deal with them. Alright, first of all let's have a look at what some of these questions might look like. As you can see, the first and the second example there have a set of brackets on the left hand side of the equation. The third one's a little bit trickier because there's some brackets and some other y's that are sitting there on the left hand side, and the fourth one has brackets on both sides of the equations. So let's have a think about how we might approach these. Firstly, we need to think about what we can do with these brackets. Usually we expand the brackets using what we call the distributive law, and you've had plenty of practice of that in the last chapter. Then it's just a matter of collecting the like terms together. What I mean by that, we're aiming to collect all of the pronumerals, the variables, on one side of the equal sign, and we'll collect all of the constant terms on the other side of the equal sign. Alright, let's have a look at that first example and see what sort of approach we can take. I've suggested that one way we can solve these is to expand the brackets by using the distributive law. So let's remember what that's all about. It means we're going to do some multiplying of both of these things. So on the left hand side we're distributing that 3 to the 2a, so we're multiplying the 3 by 2a, and of course we're multiplying the 3 by the 1. And on the right hand side we've just got 27 sitting there waiting patiently. The left hand side, you might have been able to do this in one step, now simplifies to 6a plus 3 equals to 27 on the right hand side. Now I'm going to use my knowledge of equivalent equations to try and make my next equation look a little bit simpler than the one before, and I'm going to do that by subtracting the 3 from both sides. I'm not going to write those arrows anymore, but I am going to remind myself and you of what I'm doing by just doing that at the top. So what have I got left on the left hand side is 6a, and on the right hand side is 24. And of course, how would I get that a on its own? I might be thinking about solving it by inspection and saying, well, 6 lots of what equals 24? A must have been equal to 4. Now that's a method that we can use where we expand the brackets. It just so happens that we do have a second method available for this type of question. When I say this type of question, I'm talking about one where the number that's out the front is also a factor of this number over here, and 3 is a factor of 27. So what I'm going to be suggesting for the second example that we do, or the second go at this question, is that we perhaps consider dividing both sides by 3 in that very first step, because 3 goes into both sides. What I end up with now is just 2a plus 1 equals 9. Now again I'm going to go ahead and solve this using equivalent equations. So 2a must have been equal to 8, and therefore a must have been equal to 4. Now in both cases we've got the same answer. You might like one particular method over another method. Just note this method over here always works, and the method on the right hand side only works if there's some factors. Okay, alright, let's have a look at another example. Negative 6 bracket 3h plus 5 equals negative 66. Now if you think you've got this under control, why don't you go ahead, pause the video and try and solve it yourself for h. You can use either method. How do we know that? Because the negative 6 is a factor of negative 66. So have a go at this. If you're not sure, by all means I'm going to go through one of those examples now, but if you'd like to have a go at yourself, go ahead. Alright, I'm going to, in this case, solve this one by dividing both sides by negative 6. So that will leave me on this side with just 3h plus 5, and on this side it will leave me with 11. So what have I actually done? I've divided by -6 on both sides. Okay, finding an equivalent equation now that's a little bit simpler than the 3h plus 5 equals 11. I'm going to subtract the 5 from both sides. What am I left with? 3h, and on this side, 11 take away 5 is 6. Last step, solving by inspection. 3 times what gives me an answer of 2. Well, that h must have been equal to 2. Now, if you solved it by expanding the brackets, that's quite okay. We should still have ended up with an answer of h equals 2 either way. Okay, let's move on to our I've just left you a bit of room there if you wanted to work it out the other way. Our third and our fourth example. So first of all, example 3. This one looks a little bit different. It's got this extra 3y sitting here. So in this case, I'm going to have a look at this number 4 and say, well, is it a factor of everything else that's here? No, it's not. So I don't have an option of dividing through by 4 because 4 doesn't go into the 3, it doesn't go into the 57. So I have no other option but to expand the brackets. So let's do that. That gives me 8y minus 20 plus 3y equals 57. Okay, you might need to just look at that again and be clear on where I've got those numbers from. Remember, I've expanded by distributing the 4 through everything inside that bracket. Now my next job is to have a look and see if I can collect some like terms. I've got some y's and I've got some constant terms. I'm going to focus on getting the y's together first of all. And remember, we are looking at the 8y plus the 3y to give me that 11y. And now I'm looking at collecting the constant terms together. That's the 20 and the 57 on the same side of the equal sign. It's no use shifting the 57 from here over to this side, or I'm left with 0 on this side. So I need to focus on getting the 20 or the negative 20 matched over onto the other side with the 57. I'm going to do that by plussing 20 to both sides. So I now have 11y is equal to 77. Solving by inspection, 11 times what equals 77? Y must have been equal to 7. So that particular equation there, we didn't really have too many options as to how we could solve it. That's probably the way that we're going to have to go. Alright, our final example for this video, you can see we've got brackets on both sides of the equations. Now I am going to check to see whether these factors out the front, whether we can do anything with those, but 2 doesn't go into 5, so I really don't have that ability to divide both sides by 2, so I will have to expand these brackets and solve them that way. So I'll end up with 6k plus 2 on the left hand side and 10k minus 30 on the right hand side. Right, now I need to collect these k's together. I'm collecting like terms together, and at the moment they're on opposite sides of the equal sign. We have seen some of these before in a couple of videos ago, and I said to you, or I suggested to you, to move the smaller number of letters across to the other side where the bigger number is. So at the moment we've got 10k sitting on this side, so I'm going to move the 6k. How do I move that 6k? I remove that 6k by taking it away from both sides. And that will leave me with just the 2, or positive 2 on the left hand side, and on the right hand side 4k minus 30. Now again, I want to collect the 2 and the 30 together, but they're also on opposite sides of the equal sign. So to move it across to the other side, I'm going to have to undo take away 30 by plussing 30. And of course what I do to one side, I must do to the other side. What have I got left on the right hand side now? 4k take away 30 plus 30 is just 4k. And on the left hand side I've got 2 plus 30, which is 32. Last step, solving by inspection. 32 is equal to 4 times what? Well, that k must have been equal to 8. And of course if you like to write your pronumeral first, then your answer will look like that. Okay, now in each of these examples we could have very quickly gone up and substituted our answer back in to where the k's were, and hopefully we would have equalled or found out that both signs are equal to one another. That's something you can check up once you've finished the video. Okay, so it's over to you. You've copied down these examples by now, hopefully, and you've made some sense of them, and you've also perhaps even decided that you are quite familiar with both or one of those methods that we've looked at. I want you to write a brief summary in your own words, and that should include the two different methods and when you can and can't use them. And of course, jot down any questions that you've got so that you can bring them into your next maths class. Okay, see you next time.